Hello everyone. So in this video I will talk about the part that I told you I will make a video for. It is the rest of chapter 15. So this is about the equivalent sequential circuits. If you remember in class we talked about the equivalence of the states in the transition table. Now we want to see how two sequential circuits will be equivalent. So what I have here is two transition tables for the two different sequential circuits, N1 and N2. So N1 is one of my sequential circuits, and N2 is the other one. And I have some states and transitions for each of them. So I will write those. This is the output, and for N2, the same thing, the output. Okay, so the states that I have for N1 are A, B, C, and D, and these are the next states for each of my states according to the input that I have. So in the exam, I may ask you to, so for example, I may give you two sequential circuits, the circuits themselves, and then ask you to derive the transition table and then let me know if those two circuits are the same or not. So when are we saying that two sequential circuits are the same? They will be the same if they do the same work. So if they're capable of doing the same work, then we're saying that two sequential circuits are equivalent. So let me just write these next states. So in this video, what I'm going to do, first I will draw the state graph with respect to these state tables. And that will be a review for you for drawing the state graph as well. And then we're going to go through the process of finding out if these two sequential circuits are the same or not. So let's draw the state graph first. So the state graph for N1. We know that we have state A, and if x is equal to 0, where are we going? We're going to state B, right? So if x is equal to 0, we're going to state B, and then the output for x equal to 0 is also 0. So we are at state B. Then, if you're at state A and x is equal to 1, we're going to stay at state A with the output of 0, right? So when we are at state B, so we are at the second row. When we are at state B and x is equal to 0, we're going to go to the third state, state C. So this is going to be 0, and the output is also 0. And when we are at state B, if x is equal to 1, we're going to go to the fourth state that we're going to define here, state D, which is 1. And what is the output here? So you see that if we are at state B and x is equal to 1, the output is equal to 1. So this will be 1 over 1. All right. Then if we are now, we will go to the third row. So we are at state C and x is equal to 0. Where are we going? We're going back to state A. So this is going to be 0, and the output is 0. And if x is equal to 1, we're going to stay at state 0, at state C. So that would be 1, and the output is equal to 1, right? Then we will look at the fourth row, which is a state D. So we are at state D and x is equal to 0. So we are going to state C. So this is 0, 0. And if we have x equal to 1, we're going to go to state B. So 1 and 0. All right, so this is our state graph for sequential circuit N1. Now we're going to do it for sequential circuit N2. So when we have the state graph, we can say if two sequential circuits are the same or not, because we can look at the transitions that has been done among the different states and we look at their inputs and outputs. And if everything is the same, then we can say that two sequential circuits are the same. But since sometimes we may have a big state graph, it might be hard to track all the arcs and transitions between states. That's why we will do a new method in this section. All right, so for sequential circuit N2, we have S0. So when X is equal to 0, we're going to go to some state S3 and output is 0. And if X is 1, we're going to go to S1. So this is 1 and the output is also 1. Then we are at S1 and we have X equal to 0. We're going to go to S3. So we have 0, 0. And if X is equal to 1, we're going to go back to S0. So 1, 0. Then we are at state S2. So we're going to have some state S2 here. So when we are at S2 and X is equal to 0, we're going to go back to S0. So we have 0, 0. And then if we have X equal to 1, when we are at S2, we're going to stay at S2, as you can see here. So this is going to be 1, 0. And the last state that we're going to look at is S3. So if we are at S3 and X is equal to 0, we're going to go to S2. So 0, 0. And if X is equal to 1, we're going to go all the way to S1. Oops, we have to stay at S3. Sorry. So we have to stay at S3. So 1 and 1. All right. So see, if you look at these two state graphs, since I have put each of the states wherever I want, I cannot just look at these two graphs and say that if they are the same or not. So the best way is to find these equivalence of the sequential circuits using the implication table. So remember that we used the implication table in class last session to find out if any of the states of a table they're the same or not. Now what we have to do, we want to do the same thing but this time for two different circuits. Okay, so this implication table here works such that the rows of the table will be the states of one sequential circuit and the columns will represent the states of the other sequential circuit. So it will be like we have this square here as my implication table. So I have 4 different states in each of my sequential circuits. So I think yeah, that's great. So the columns here, they are representing A, B, C, and D. So the states of one of the machines, one of the sequential circuits, and the rows will be for the other one. So S0, S1, S2, and S3. All right, so I'm going to draw a line here so you won't get confused. All right. Now I have to fill in this implication table. So it works exactly like what we had before, but this time for in two different tables, you have to look at them. So what I'm going to do, I will compare everything in sequential circuit N1 with everything in sequential circuit N2, one by one. For example, I want to compare state A, with all other states, with all 4 states of N2. So basically I have to compare A with S0, with S1, with S2, and with S3. Okay? So note that here you have to be careful about the outputs because sometimes since they are in 2 different tables, you may get confused and you may not look at the outputs. Okay, so be careful about that. For example, I want to compare A with S0. So whatever the result is, I have to put it in the cell that represents A and S0 in the table. Which one is that? It is this table over here, this cell over here, right? It is A and S0. All right? Okay. So A and S0, can I have any condition that A and S0 are equivalent states? No. Why? Because their outputs are completely different. So you look at the outputs here. The outputs of A are 0, 0 for both x equal to 0 and x equal to 1. But for S0, I have 0 and 1. So these two can never be equivalent. Now, I'm going to compare A with S1. Let's see if I can do that. Can I compare A with S1? So A and S1. A is 0, 0. S1, it has output of 0 and 0. So I can compare them. Okay, so they will be the same if their states in specific inputs are the same. So for state A, when input is 0, when x is equal to 0, I have B. For state S1, when x is 0, I have S3. So B should be equal to S3. Okay, so this is one of my conditions. And the other condition is when x is equal to 1. So A should be equal to S0. Okay, so I compared A and S1. Now, A with S2, still the output is 0, 0, so I can compare them. So we can say that B, if B is equal to S0 and A is equal to S2, then they're the same. I will explain this once more. So why am I doing that? Because if I look at state A, when x is equal to 0, I have state B. So my next state will be B. And in S2, if x is 0, my next state will be S0. So if B and S0 are the same, it means that these two states are the same, and also and this condition, which is for x equal to 1. So A and S2. Okay? Now A with S3, we cannot compare them because the outputs are different. So I'll put a cross here. All right? Now let's go back to N1, to sequential circuit N1, and compare B, state B, with all the states in N2. Okay, so B with S0. Can we compare them? Yes, because their outputs are the same. So 0, 1, and 0, 1. So when x is equal to 0, C should be equal to S3, and D should be equal to S1. Okay, now B with S1 and S2, we cannot compare it because their outputs are different. As you can see, outputs are 0, 0, 0, 0, but with S3, I can still compare B. So B with S3, what should be the conditions? So C should be equal to S2 and D equal to S3. All right, so I will do the same procedure for state C of machine N1. So C with S0, I can compare it because they have the same output. So I am at this row over here. So C with S0. So A should be equal to S3 and C equal to S1. So basically when I'm writing C dash S1, it means that state C and state S1 should be equivalent. Okay, so C cannot be compared with S1 and S2 because the outputs are different. Then if I want to compare C with S3, because they have the same output, so A should be equal to equivalent to S2, and C should be equivalent to S3. All right, so one more state, which is state D. I can't compare D with S0 and S3. I can say right away because their outputs are different, right? So B with S1, no, D, sorry, state D with S1, they have the same outputs. The outputs are 0, 0. So C and S3 should be equivalent, and also B and S2. Oh, we are at S2 actually. So here this should be S0. So we are at, oh, we were doing S1. Okay, so this should come to the next cell. So what happens is that I was comparing D with S2, and I was writing the result in the cell S1. Okay, so I was comparing it with this row over here. Now the only cell that is left is S1, D and S1, so I have to compare D with S1. So C should be equal to S3 and B should be equal to S0. All right. Okay, so now we have our implication table, but we are still not done because we have to look more into the table to see if any other not valid states are there. So by not valid, I mean when we set the condition of two states to be equivalent, but they cannot be because of the specifications of the circuit. So you can see here what I mean. So when we look at this implication table, we see that A S0 so A and S0 can never be equivalent. Why? Because here I have this big cross here. So A and S0 can never be equivalent. So all the crosses are the states that can never be equivalent. Okay, so I will write them down here. So we have A S0, A S3, B S1, BS1, BS2, CS1, CS2, DS0, and DS3. So these are the equivalents, these are the states that can never be equivalent with each other. Okay, so I'm going to look into the conditions that I put out there, and if I have any of these conditions, I'm going to cross that cell out, so that can never happen. For example, if you look at this cell over here, okay, so this is the cell AS1. So in AS1, one of the conditions is that A and S0 should be equivalent. But if I look at my list here, A and S0 can never be equivalent, okay? So this condition will be crossed out. All right, so let's see if we have any other things to cross out. Okay, so AS3 can never happen, so AS3 will go out. Then BS1, we don't have such a condition. BS2, we have the condition over here. Then we have CS1, we don't have such a condition. We have CS2, so CS2 can never happen. And then DS0 and DS3, so we don't have this condition at all. So only 4 of the states are remaining, right? 4 of the conditions that we put out there. So the thing is that we will look more into the table to see if any of these conditions are not, it's not valid. But if we look at the table, there is no other conditions that are not valid, because how can you do that? So when I add more crosses to this implication table, I can add to this list over here. So what is it? What has been added to this list over here? AS1, BS3, CS0, and DS2. Okay, so now these are the list that cannot happen, and we don't have any of them in the 4 remaining cells, right? So I have this implication here. This is the final implication table that I have, but we're still not done. So for example, if in an example in the exam I ask you if 2 sequential circuits are the same or not, by the same I mean if they are equivalent or not, you have to go through this process, draw the implication table, and then whatever is left here for these charts, for these cells, you have to say that, okay, these 2 sequential circuits are the same if state C is equivalent to S3, state D is equivalent to S1, state A is equivalent to S2 and state B is equivalent to S0. Okay, so you look at the cells that are remaining. So these are the conditions that if they happen, we can say that two sequential circuits are the same. All right. Okay, so this section was the last section that we have in chapter 15 that will be covered in your exam. So please make sure that you understand this material before your class on Tuesday. And if you have any questions, you can contact me. And also, if you have any questions, you can leave it in the comments down below. And see you in the next video. Thanks for watching.